In this video, we're going to look at long division of polynomials, but before we do that, let's just do a quick review of long division of numbers. I've got 76 here divided by 5, so I'm going to set it up in the traditional long division format. Just a reminder that what I'm dividing by is called my divisor. What I'm dividing into is my dividend. The answer I get when I divide is called the quotient, and the leftover at the end is the remainder, but we'll get to that. So just a reminder as to how this process goes, because it's going to go similarly for polynomials. So we take our divisor, 5, and we divide it into, we try the first number here, 7, and it does go once, and so we put that up top. 1 times 5 is 5. We then subtract and bring down one number, and then we repeat the process. 5 divided into 26, that would go 5 times. 5 times 5 is 25. Subtract to get 1, and since there's nothing more to bring down, we are finished, and this is our remainder. And remember that we can check our work with something called the division statement. This statement should be true if we've divided correctly. That is that our dividend, which is 76, should equal our divisor, which is 5 above, multiplied by our quotient, which is 15, plus our remainder, which is 1. And if I work that out, 5 times 15 is 75, plus 1 is 76. I know that this statement is true. Now there is another way that we can write this statement, and that is that if we look at our 76 equals line here, I could take this line and divide both sides by 5, which is my divisor, and that would give me 76 divided by 5 is equal to 15 plus 1/5. And I can see that that is true. This is 15 and 1/5, and so is this. All right? In other words, my statement here, my dividend, which I'm going to call P, equaling divisor times quotient plus remainder, is sometimes written, if we divide both sides by D, as P divided by D equals Q plus the remainder divided by D. Okay, these are two equivalent forms. So I said that we can do this long division process with polynomials, so let's look at that. We have a cubic divided by x minus 2 here, so I'm going to set this up in the traditional long division format. What I need to be careful about, though, is that with my dividend, what I'm dividing up, my cubic, I'm going to start with the highest power, x cubed, and go down in order of degree. So I have x to the third. Now I need my second degree term, which is 7x squared, my first degree term, and my constant. It's important that you go in order of degree. And if one of the, let's suppose our dividend hadn't had this term, let's suppose that wasn't there, then what I would have done in this spot is I would have put in a 0x squared. I need to have a place for each power, starting with the highest, going down to the lowest. All right, so back to our original question, and then our divisor goes into its spot again, highest to lowest degree, degree 1 minus 2. All right, so now the division process goes similar to what it does with numbers. I'm going to take the first term of the divisor and divide it into the first part of the dividend. In other words, I'm going to go x into x cubed. I'll do my scratch work over on the right here. That's x cubed divided by x. If I divide those, I know that that's subtraction of exponents, x squared, and so x squared goes up top. And then, as with numbers, we take what's on top and we multiply it to each of the terms in the divisor. So in other words, we take our x squared up top and we multiply it into x minus 2, which means distribution. So I'm going to distribute these two terms, and I'm going to write that answer below here, x cubed minus 2x squared. Draw a line, and this is where we subtract. So subtract our terms vertically. X cubed minus x cubed is 0. Those go away. And here I've got 7 take away negative 2. 7 take away negative 2. Okay, I'm subtracting. There's an extra negative being inserted here. So 7 take away negative 2 is 9x squared. And then we bring down one term just as we do with long division of numbers. We then repeat the process. The first term of the divisor into the first term of what's here. So x into 9x squared. X into that. Do my division. That's going to be 9x. And that goes up on top. I then take my 9x and I distribute it to both terms on the divisor. So that's going to be 9x times x minus 2, distribute, and when I multiply that out, I write that down here, minus 18x. Put my line and subtract. I'm now going to subtract 9x squared minus 9x squared is 0. And I've got negative 3 take away negative 18, which is 15x when I subtract. I have one more term to bring down, so I'm not finished. Bring that down. Just going to erase some of the scratch work here on the side to make room. And so I'm going to take my first term of my divisor into what's below. So x into 15x. Dividing would be 15, so that goes up top. And then the 15 up top gets distributed to both terms in the divisor. That will be 15x minus 30. 15x minus 15x is 0. And then 4 take away negative 30 will be 34. And since there's nothing more to bring down, this will be my remainder. And now, of course, I can check my work with my division statement. My dividend, which is my polynomial, p of x, I'll call it, that should equal my divisor, d of x, times my quotient, q of x, plus my remainder. Let's see if this is true. So my dividend, which is the cubic, does that equal x minus 2 multiplied by my quotient on top plus my remainder at the bottom. So, working out, simplifying the right side, that'll be x cubed plus 9x squared plus 15x, negative 2x squared minus 18x minus 30 plus 34, that equals x cubed plus 7x squared minus 3x plus 4. The left and the right sides are equal, so I know I've done my work correctly. And as I said before with numbers, we can also write our division statement as our polynomial divided by our divisor to equal our quotient plus our remainder divided by our divisor. So in this case, that would look like this. Plus our remainder divided by our divisor, with the condition that x can't be 2. Next, I want to show you a shortened, modified version of long division that we can use to divide some types of polynomials. This is called synthetic division, and you can only use it if your divisor is of the form 1x plus or minus a number. We're going to call it x minus a. And so I have a situation like that here. In fact, this is the first example I did with long division, but I'm now going to do it with synthetic division. You'll notice that my divisor is of the form x minus a. My a value is 2. All right, and this is what I'm going to do. I'm going to put a box here, and my a value goes in the box, which is 2. And then I'm going to list the coefficients of my dividend in order from highest to lowest degree, just the coefficients. So coefficient is 1, coefficient is 7, -3, 4. I'm going to leave a space, and then I'm going to draw a line. All right, so what I'm doing here is kind of a shortened version of long division, leaving a lot of the x's out. It's a similar process, but it's been modified a little bit. And this is how it goes. So you got it set up as so. You start with your 1 and you bring it down and just put it down there. You then do this number multiplied by the number in the box. That's 2, and you put that here. You then add your terms. So that's one major difference from long division, is you add the terms here, and that's 9. 9 times 2 is 18. That goes here. We're repeating the process now. We add these terms, and we get 15. And one more time with the process, 15 times 2, that's going to be 30, which is here. And if we add the terms, we get 34. Now, if you look back at your first example, you'll recognize the 34 as the remainder. And you'll recognize these numbers as the coefficients of the quotient. In other words, we have our remainder, and then our quotient would just be 1x, and the power on that's going to be 1 less than the power on the polynomial, because if x has been divided into x cubed, we're down 1 power. So this is going to be, my quotient is going to be 1x squared plus 9x, it's coefficient, 1 power less, plus 15. And you can see that our answers match what we had in the first example when we did long division. So just one more example on that. I have a divisor divided by x plus 1. And x plus 1 is of the form x minus a number, because I can think of it like this. X minus, this is my a value. Okay, so in the box goes the a value. And the coefficients of my dividend, it's a 4th degree, so I need every power represented from power 4 down to the constant. The coefficient of power 4 is 1. Coefficient of power 3. There is no x squared term, which really means there's a plus x, 0x squared. So I'm going to put a 0 in for the x squared coefficient, -3 for the x term, and 4 for the constant. Leave a line, draw a line, and here we go. Synthetic division. I bring down the first number. I take this number and multiply by the number in the box, and I get -1. I then add these numbers, -3. -3 times -1 is going to be +3. Add these numbers, 3. Multiply these numbers, -3. Add these numbers, -6. Multiply these numbers, +6. Add these numbers, +10. So when I divided my polynomial, I got a remainder of this, in which this is a cubic, 1x cubed minus 3x squared plus 3x minus 6, plus a remainder of 10 divided by my divisor. Remember, what I'm doing here at the end is writing my answer as polynomial divided by divisor is equal to quotient plus remainder divided by divisor.